Welcome to Two Projects. In this video, we are going to explain the project Kidney Stone Detection using Yolov5. So before diving into the execution, let me give you an overview of the project. So what are kidney stones? Kidney stones are solid deposits of minerals and salts that form inside the kidneys, causing severe pain, urinary tract infections, and other complications. Early detection is crucial for timely treatment and prevention of complications. But traditional methods such as manual examination of medical images like CT scans are time consuming and prone to human error. So there comes deep learning and computer vision. Deep learning and computer vision technologies offer a promising solution to automate and improve the accuracy of kidney stone detection. By training models on large datasets of medical images, deep learning algorithms can learn to identify patterns and features associated with kidney stones with high precision. And YOLO, that is, you only look once, is a state of the art object detection algorithm which is particularly well suited for this task due to its speed and accuracy in detecting objects within images. So the workflow involves exploring the dataset, where dataset involves CT scan images of kidney, followed by image processing and data augmentation. So the model distinguishes between kidney stone presence and absence, declares bounding boxes around suspected stone regions, and converts images into NumPy arrays for manipulation. So this is what happens in image processing, and data augmentation involves techniques like randomizing, rotating images, translation, scaling, and sharing to enhance the dataset's diversity and enable the model to handle imaging conditions effectively. So these steps form the foundation for robust model training, improving the accuracy and generalization capabilities of kidney stone detection models. And these pre-processed images are used to build the detection models YOLO V5, YOLO V6, and YOLO V7. And the benefits of the project include early detection of kidney stones leading to timely treatment and better health outcomes, aiding healthcare professionals in making more accurate diagnosis. The primary objective of the project is to develop a robust and accurate deep learning model based on YOLO V5 architecture capable of detecting kidney stones in CT scan images. So, this will improve diagnostic efficiency, reduce manual workload for healthcare professionals, and ultimately enhance patient care and outcomes. Now, we'll see the software and hardware requirements. So, software requirements are: software needed is Anaconda, primary language needed is Python, front end framework required is Flask, back end framework required is Jupyter Notebook, database needed is SQLite 3, and front-end technologies required are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements required are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now we'll understand about the algorithms built in brief. So YOLO, that is you only look once, is a computer vision object detection algorithm that quickly identifies objects in images by splitting the input image into a grid and simultaneously predicting bounding boxes and class probabilities. Unlike traditional methods, YOLO processes the image just once, making it extremely fast. It predicts multiple bounding boxes and their associated class probabilities for each grid cell and then removes redundant detections using non maximum suppression. So this results in a final list of detected objects along with their bounding boxes and probabilities. So these are different architectures in YOLO, YOLO V5, YOLO V6, and YOLO V7. So in this project, we have proposed YOLO V5. We have built YOLO V6 and YOLO V7 for comparison. So YOLO V5 is known for its balanced performance between accuracy and speed. This version relies on a backbone network called CSP Darknet 53. It utilizes focus modules for downsampling and path aggregation network that is span for feature fusion, enhancing object detection across different scales. Coming to Yolov5, this model introduces a key difference by using efficient net L2 as its backbone network. Compared to efficient net used in Yolov5, efficient net is known for its efficiency with fewer parameters, and Yolov5 also employs a novel dense anchor box generation method to improve object detection accuracy. The next one is Yolov5. So Yolov5 uses a modified version of the Swin transformer architecture as its backbone. This architecture leverages self-attention mechanisms, leading to better feature extraction compared to convolutional neural networks used in prior versions. So after comparing all these three algorithms, we have observed that Yolov5 has outperformed Yolov5 and Yolov5 in all the performance metrics, that is map, precision and recall. So we have deployed Yolov5 in the Flask framework. Now we'll see the execution. So to execute the project, first we need to open the code folder which contains the project source code files. So this is the code folder. This is annotations folder in which I have these annotation files. So they contain metadata about the objects within images, including their locations and classes. So each annotation file corresponds to an image file in the images folder and provides essential information for tasks like object detection. So this annotation file corresponds to this image. Similarly, this annotation file corresponds to this image. In the same way, each annotation file corresponds to an image file in the images folder. We can see there are 716 annotation files and there are 716 images. So these files contain metadata. So metadata includes details such as the image file name, path, dimensions, source, and segmentation status. Coming to images folder, so in images folder, I have these CT scan images of kidney. So I have two classes of images, normal and containing stones. So using these images and annotation files, we will train the deep learning models, that is YOLO models. Before training the models, we will split this dataset, the annotation files and images files, into three subsets: train, test, and validation. So after splitting the dataset into three subsets, these three folders have been formed. So I'm opening the train folder. Now in train set, I have 500 images and 500 annotation files. So on these files, we will train the models. Coming to validation folder, now I have 142 images and 142 annotation files in validation folder. So the validation set is another subset of the data set used to fine tune the models. And in test set, now I have 74 images and 74 annotation files. So on this data set, we will evaluate the model's performance. So this test data set is used to assess the model's performance after training is completed. So this is about the data set. Now we'll see other folders. This is samples folder in which I have images again. So using on these images, we'll make the detections. This is static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. These are model files which contain algorithm information. So these files will be loaded into the project code during runtime to utilize the trained models. This is notebook Jupyter source file. So this file contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. Now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open Anaconda prompt. Use the command cd followed by space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command executes the Python script and perform runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address localhost and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. And here we can see a login link. Click on it. We have to provide a credentials, username and password here and click on login button to sign in. And if we are new to the system, we have to register ourselves first. Click on sign up link, fill in these details and click on register button to sign up. So as I'm already a member, I'm signing in. Click on sign in link. I'm giving my credentials here and click on login. So it has redirected us to the detection page. So now we have to upload any CT scan image here and the application will detect the stones from the image. Click on choose file button. So from sample images folder, I'm selecting this image. Click on open. The image has been loaded. Now click on upload button. So we can see there are no stones detected. It is normal. Click on back. We'll try giving another image. Click on choose file button. Select the image. I'm selecting this one. Click on open. The image has been loaded. Now click on upload button. So we can see there are so many stones detected. The application has drawn a bounding box around the detected stones and it has classified them as kidney stones. And we can see a probability score here telling us the confidence level of detection and classification. We will try again. Click on choose file, select the image, click on open and click on upload. So we can see a stone has been detected and the application has drawn a bounding box around the detected stone. It has classified it as kidney stone and we can see the probability score here. Click on back. So we can also take the images from test images folder. So we can test the system using these images also. So I'm selecting this image, click on open. The image has been loaded. Now click on upload button. So we can see there are no stones detected. It is normal. Click on back. Click on choose file. We'll try with this one. We can see there are two stones detected. We can see the bounding box drawn around the detected stones and we can see the probability score. Click on choose file. I'm uploading this image. Image has been loaded. Click on upload button. So we can see the application has detected the stone. It has drawn a bounding box around the detected stone. And we can see the classification and the probability score. So we can see this time the orientation has been changed. I think the person is laying down. Choose file. So we can try with different images. Click on open, select the image and click on open. The image has been loaded. Click on upload. So we can see the application has detected the stones. It has classified them as kidney stones and we can see the probability score. So we can see how well the application has generalized to different images. This time I'm selecting this one. We can see there are no stones detected. Similarly, we can upload any CT scan image and can get the detections if it is normal or if it contains stones. Now click on sign out. So the project utilized Yolov5 for kidney stone detection, leveraging deep learning and computer vision. Through data exploration, image pre-processing, and model building, it automated detection, enhancing diagnostic efficiency and improving patient care in kidney stone diagnosis.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.